Good evening, friends. Welcome to my class Ganit Shala. Today morning I posted a video on this trigonometric ratio, that is exercise 8.4, question number 1 to 4. So this particular syllabus is related to CBSE 10th standard, and subsequent to that video which I posted in the morning, I am going to post now the video for question number 5, that is prove that questions. So that prove that question, now we are going to solve in this question number 5. So all of you are ready. I feel that you all are ready for the class now. Especially many of our students, they asked me that if in trigonometric ratio, if video can be posted, then it will be useful for all those students who are not able to approach some expensive coaching classes, or somewhere they feel that some extra information, if they will get, they will certainly have success. Let us go for solving question number 5 from exercise 8.4. So the question is, prove the following identities where the angles involved are acute angles for which the expressions are defined. First of all of us should know that what is called an acute angle. Okay, what is called an acute angle? So the angle between 0 degree to 90 degree is called an acute angle. Perfectly, if it is 90 degree, then it will be right angle. Okay, so the angle between 0 to 90 degree is called an acute angle. So here whatever the expressions are given, trigonometric ratios, all those expressions, this theta is there, so that theta is actually the angle, and theta is between 0 to 90. Between 0 to 90. So this particular concept we have to keep it in mind, and let us go for solving it. So we need to prove. Prove means what? LHS, and in between equal to sign is there, so RHS. We have to take any one. If we are taking RHS, then we have to prove LHS, means RHS is equal to LHS, or we can take, so see, there are many ways, some 3 ways are there by which we can solve this type of question. Once we can take LHS, we can go for solving it subsequent step, LHS 1, then LHS 2, and then lastly we will be getting RHS, and in that case we can say that LHS is equal to RHS, so hence proved. Hence proved. Similarly, we can also take RHS. We can also take RHS, and then RHS 1 we will be solving it, then RHS 2 we will solving it, and then lastly we will be getting LHS. Then again LHS will be equal to RHS. So this is the first way, this is the second way, and the third way is what? LHS we are solving, we get something LHS 1. RHS we will be solving, and we will be getting RHS 1, which will be equal to LHS 1. Which will be equal to LHS 1. And then in that case, what we can say that LHS is also equal to LHS 1. Similarly, RHS is also equal to LHS 1. So LHS is equal to RHS. What is LHS and RHS? Left hand side, this is called left hand side, this is called right hand side of the equation. The equation sign when equal to is there, then only it is becoming an equation, and this is called LHS, and right hand side of the equal to is called RHS. Okay? Yes. Then let us proceed for solving it. So from question number 1, we take as LHS, and that is equal to cosecant theta minus cot theta whole square. Now we will solve it. Fine. Cosecant theta is 1 by sin theta minus cot theta is cos theta by sin theta square. This will be giving us as 1 minus cos theta by sin theta square. Okay? So 1 minus cos theta by sin theta. Now further, it will be giving us 1 minus cos theta whole square divided by sin square theta. Further, here, so 1 minus cos theta square divided by, as we have already seen in my previous video, so there is a formula sin square theta is equal to 1 minus cos square theta. So it will become 1 minus cos square theta. Further, we can write as 1 minus cos theta square divided by 1 minus cos theta and 1 plus cos theta. Why we are writing? Because we know that a square minus b square is equal to a minus b into a plus b. So 1 can be written as 1 square and minus cos theta can be written as cos square theta can be written as cos theta square, and it is giving us as 1 minus cos theta and 1 plus cos theta. Now from here, this 1 minus cos theta and 1 minus cos theta will get cancelled. Left with what? 1 minus cos theta divided by 1 plus cos theta, and this is equal to what? RHS. This is equal to RHS. So this LHS has become RHS now. So this is the way we solved question number 1. Now let us go to solve question number 2, and before that, these right hand side whatever I have written, let me erase it so that I will get space also for solving question number 2. So you have already seen that the formulas which we have already mentioned in my previous videos, that which I have posted today morning, how we are going to utilize it. Certainly we have to utilize all those formulas which you have learned. Please do not forget to see my video which I have posted in the morning. If you will see that video, then only it will be possible that you will be in a position to understand this question number 5. So directly if you are jumping to this question number 5, maybe you would be missing the basic concepts which we have already discussed. Okay, second one. So, okay, let us take LHS only. Generally the bigger expression is taken, and here in RHS we do have a smaller expression. So from this smaller expression, In order to get that bigger expression, it will be a difficult task. Means difficult means we have to go for many of the procedures, many of the steps. It's better from bigger expression can be reduced to a smaller expression. So we will take LHS. In this case, cos A by 1 plus sin A plus 1 plus sin A by cos A. Okay. When we take LCM, so that LCM is becoming 1 plus sin A into cos A. So here it will become, in this 1 plus sin A is there, cos A, this cos A has to be added. So cos A square means cos square A, it will become cos A into cos A will become cos square A. Similarly, in this case 1 plus sin A has to be multiplied. So 1 plus sin A whole square. Fine. Then here we will solve it. Cos square A plus, now 1 plus sin A, we will use the formula A plus B whole square. So what it is, A plus B whole square? The formula says that A square plus B square plus 2AB. So cos square A plus, now 1 square is 1 plus B square is sin square A plus 2 into 1 into sin A. So 2 into 1 is 2 and sin A, 2 sin A divided by 1 plus sin A and cos A. Okay, let me erase these formulas which I have written here. Okay. So the formula you know, cos square A plus sin square A is equal to 1. So this formula, cos square A plus sin square A is equal to 1. So here we can see cos square A and sin square A. So this one, addition of both of them will give as 1. So 1 plus 1 plus 2 sin A by 1 plus sin A and then cos A. Further, it will give us 1 plus 1, 2. So 2 will become common and we can write as 1 plus sin A. Let me write it properly, so don't get confused. Right, let me erase the formulas which I have used already, so you are already knowing, and in this way I will get the space for writing further. So this one will come 1 plus 1 is 2 plus 2 sin A by 1 plus sin A and then cos A, right? This 2 plus 2 sin A can be written as 2 in bracket sin A divided by 1 plus sin A and cos A. So 1 plus sin A, 1 plus sin A has got cancelled and it will become 2 by cos A. This is 2 secant A. As we know that 1 by cos A is equal to secant A, and this is what? This is RHS. Hence LHS is equal to RHS. So prove. So this is all about second question. Let us go to next question, that is third question. Again here the bigger expression is in left hand side. So tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Hint is already given that we can convert tan theta and cot theta in terms of sin theta and cos theta, so that we can write. So tan theta can be written as sin theta by cos theta, and 1 minus cot theta can be written as cos theta by sin theta, plus cot theta is cos theta by sin theta divided by 1 minus sin theta by cos theta. Now, so this one will become sin theta by cos theta. So here we are taking LCM, so it will become into, denominator will go at the top, numerator will be sin theta minus cos theta, then in between plus again cos theta by sin theta into cos theta, same way, and it will become cos theta minus sin theta. Okay, right. Now further, next step. So here it is. Right. So from here we are going to this place. So it has become sin square theta divided by cos theta into sin theta minus cos theta plus cos square theta divided by sin theta and cos theta minus sin theta. Further, see here sin theta minus cos theta is there, whereas here cos theta minus sin theta is there. Okay, so actually we can also write as cos theta minus sin theta can also be written as minus of, okay, minus of sin theta minus cos theta, minus of sin theta minus cos theta in bracket. So in that case it will become sin square theta divided by cos theta sin theta minus cos theta, and here it will become minus cos square theta, so that in the denominator we can write it as sin theta minus cos theta, like this. Okay, right, fine. Now the denominator has become same to same, so we can write as cos theta, okay, sin square theta minus cos square theta, we need to prove as 1 plus secant theta cosecant theta. So sin theta minus cos theta is common to them, common. So sine square fine. So if we are taking LCM, so in case LCM is there, then it will become cos theta sin theta, and it will become sin theta minus cos theta, sin theta minus cos theta. And here it will become because here sin theta is not there in the denominator, so sin theta will get multiplied and it will become sin cube theta minus, here cos theta is not there, so it will become cos cube theta. Now the formula we are going to utilize, and which is that formula? The formula is a cube minus b cube. So it will be a minus b into a square plus ab plus b square. Okay, so a minus b into a square plus ab plus b square. So this formula we are going to utilize, so it will become sin theta minus cos theta, and in bracket a square is sin square theta plus sin theta cos theta plus cos square theta divided by cos theta sin theta into sin theta minus cos theta. So this and this will get cancelled, right? And now, so it will become sin square theta, okay. Now space I need, so it is becoming sin square theta plus cos square theta, that will become 1, right? Okay, so 1 by cos theta sin theta, 1 by cos theta sin theta, okay, plus sin theta cos theta divided by sin theta cos theta, so both will get cancelled, will be giving to us as 1. From this expression we will get 1 plus, so 1 by cos theta is what? Secant theta. 1 by sin theta is what? Cosecant theta. And this is RHS. Hence we have approved. We have proved it. So this proving step by step, simultaneously utilizing all algebraic formulas are very, very important. So we must be aware of utilizing the formula which we have already studied in algebra. Now question number 4. So here hint is given to us that we need to simplify LHS and RHS separately. So LHS, let us first simplify, is equal to 1 plus secant A by secant A. Now if we are converting it as 1 plus 1 by cos A, and it is 1 by cos A, so it will become 1 plus cos A, 1 plus cos A, or cos A plus 1 you can write, no problem. 1 plus cos A divided by cos A, and then again divided by 1 by cos A. So this cos A will get cancelled, left with 1 plus cos A. Similarly, RHS we are going to solve. So RHS is what? Sin square A by 1 minus cos A. Sin square A will be equal to what? 1 minus cos square A by 1 minus cos A. So the formula is what? Sin square A is equal to 1 minus cos square A. So 1 minus cos square A can be written as 1 minus cos A by 1 plus cos A divided by 1 minus cos A. Which formula we have used? We have used A square minus B square is equal to A minus B into A plus B. So 1 square is equal to 1 only. Okay. So 1 is written as 1 square. So A is equal to 1 and B is equal to cos A. Now this 1 minus cos A, 1 minus cos A has got cancelled, and we got 1 plus cos A. So now what we have seen? We have seen that LHS is equal to 1 plus cos A, and this is also equal to RHS. Hence proved. Right. Fifth one. So we are going to solve that fifth one. Okay. Let us move towards fifth question, and it is given to us as, let us take LHS. Even we are given hint also using the identity. Okay. So cos A minus sin A plus 1 and cos A plus sin A minus 1. Okay. So now this particular question we need to solve. Right. Let us go for dividing it, because cos A is there, sin A is there. We need to make it as cosecant A and cot A. We have to get cosecant A plus cot A. So that particular part we need to find it out. So what we'll do, let us divide by cos A So it will become cos A minus sin A plus 1, or we will divide by sin A. Let us divide it by sin A. Then again cos A plus sin A minus 1 divided by sin A. So we will not cancel it because we purposely divided it. So cos A by sin A is cot A minus sin A by sin A is 1 plus 1 by sin A is cosecant A divided by again cos A by sin A cot A plus sin A by sin A plus 1 minus cosecant A. So minus cosecant A. So this expression we have already got it in terms of we can say that cot A and cosecant A. Okay. Yes. So next step we are going for rationalization. So cot A minus 1 plus cosecant A divided by cot A plus 1 minus cosecant A. We will rationalize it by multiplying both numerator and denominator with cot A plus 1 plus cosecant A by cot A plus 1 plus cosecant A, because we have to utilize the formula which is given here, that is cosecant square A is equal to 1 plus cot square A. So that's the reason we are going to have this rationalization. Now, so this cot A and this cosecant A, cot A plus cosecant A, cot A plus cosecant A is also there. Okay, here minus 1 is there, here plus 1 is there. So it means it is following the rule of A minus B into A plus B. So it will become cot A plus cosecant A whole square minus 1, means A square minus B square. Similarly, in denominator, we can see that it is cot A plus 1 is same. Here plus cosecant A is there, here minus cosecant A is there. So it means it will become cot A plus 1 whole square minus cosecant square A. Let me remove it. So you have understood that is the main requirement. Okay, fine. Now we will solve it. So it will become cot square A plus cosecant square A, okay, plus 2 cot A cosecant A minus 1 divided by cot square A plus 1 plus 2 cot A minus cosecant square A. So let us write the formula itself here. So it is minus, so minus 1 minus cot square A. So So now this cot square A and this cot square A will get cancelled. This 1 and this minus 1 will get cancelled. Okay. Similarly, this cosecant square A minus 1. So we can find it out from here. Cosecant square A minus 1 is equal to cot square A. Okay. So we can very well write cot square A plus, due to this cosecant square A and minus 1, so further we can write cot square A plus 2 cot A cosecant A. Okay, let me write directly. So this cot square A will give what? 2 cot square A. Okay, 2 cot square A plus this we can write 2 cot A cosecant A divided by 2 cot A. Okay, so further 2 cot A we can take as common, so it will become cot A plus cosecant A divided by 2 cot A. So this 2 will get cancelled, cot A will get cancelled, and left with cot A plus cosecant A, and which is equal to RHS. So this is the way we have to solve this question. Okay, let us go for question number 6 now. So here we will take LHS. So whole root 1 plus sine A by 1 minus sine A. Again we will be going for rationalization, that is 1 plus sine A by 1 minus sine A into 1 plus sine A divided by 1 plus sine A, and this is given to us as 1 plus sine A whole square divided by whole root 1 minus sine A into 1 plus sine A, it is 1 minus sine square A, can be written as 1 plus sine A after coming out from the square root, and 1 minus sine square A, we are already aware that it is cos square A. Okay, it is cos square A, so which can also be written as 1 plus sine A by cos A. So 1 by cos A is secant A plus sine A by cos A is tan A, and it is equal to RHS. Okay. Next one, 7th one, sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. We have to prove it as tan theta. Okay, right. So if we will take sine theta common here, then it will become 1 minus 2 sine square theta divided by, if we are taking cos theta here, right, then it will become 2 cos square theta minus 1. Okay. Then further, sin theta by cos theta is tan theta. no doubt. Okay, in bracket we will put. So 1 minus 2 sine square theta. So 1 minus 2, in place of sine square theta I am putting 1 minus cos square theta divided by 2 cos square theta minus 1 is equal to tan theta 1 minus 2, and minus minus it will become plus, so 2 cos square theta divided by 2 cos theta minus 1. Then tan theta, so 1 minus 2 is minus 1, so it will become 2 cos square theta minus 1 divided by 2 cos square theta minus 1. So numerator and denominator got cancelled, left with only tan theta. Next question. So LHS is equal to sin A plus cosecant A whole square plus cos A plus secant A whole square. So it is given as tan square A plus cot square A we need to prove. Okay. So tan is also there, cot is also there. Fine, let us solve. So we will go for A plus B whole square. So sin square A plus cosecant square A plus 2 sin A cosecant A plus cos square A plus secant square A plus 2 cos A secant A. So this sin square A plus cos square A will become 2, will become 1. By using the formula sin square A plus cos square A is equal to 1. Okay, right. Cosecant square A is there and secant square A is there. Okay, so cosecant square A, just now in previous question we saw that 1 plus cot square A. So cosecant square A we will write as 1 plus cot square A. Okay, right, plus 2 sin A cosecant A. So sin A cosecant A is equal to 1. Similarly cos A and secant A is equal to 1. So it will become 2 into 1, so 2 plus cos square A is already over, and plus secant square A we can write that 1 plus tan square A. So 1 plus tan square A. Again 2 cos A secant A is 2 into 1, 2. So now 1 plus 1, 2 plus 2, 4, 5, 5 plus 2, 7. So this has become 7 plus tan square A plus cot square A, and this is RHS. So proved. Okay, ninth one. Here we need to simplify LHS and RHS separately, so we'll do that. LHS is equal to cosecant A minus sin A and secant A minus cos A. So this one will become cosecant A minus sin A and cosecant A minus cos A. Okay. So if we are multiplying, let us multiply cosecant A secant A minus cosecant A cos A, then minus sin A secant A minus sin A cos A. Okay, right. So cosecant A secant A can be written as 1 by sin theta cos theta. Okay, cosecant A cos A. Similarly, sin A secant A is there and sin A cos A. So sin A 1 minus, okay, fine. So here if we are going for completely sin and cos, then it will become 1 by sin A cos A minus, here it will become cos A by sin A, means cot A, minus sin A by secant A, sorry, not secant A, cos A, sin A by okay. This one sin A by cos A, and here minus sin A cos A. Okay, if we'll take it completely, so our denominator will become sin A cos A. So it will become 1 minus, so here sin A is already there, so cos A. So cos square A minus, here cos A is there, so sin square A. Okay, minus here sin square A cos square A. Fine. So cos square A minus sin square A. So it will give what? 1 minus, in bracket we can write cos square A plus sin square A minus sin square A cos square A divided by sin A cos A. So in this case we can get this cos square A plus sin square A is equal to 1. So 1 minus 1, 1 minus 1 and minus sin square A cos square A divided by sin A cos A. So this 1 minus 1 will get cancelled. Okay. Similarly, sin A will be cancelling 1 sin A in numerator, cos A will be cancelling 1 cos A. So we will get sin A cos A. Right? Yes. So this we got from LHS. Now we have to see that we are getting it from RHS also. Okay. Minus sin A minus cos A, sorry, it will become plus here. I am sorry, it will become plus here. So this is plus, this is also plus, and this is also plus. This is not minus, this is plus, sin A cos A. Now let us move to RHS side. So 1 by 10A plus cot A. Okay. So 1 by 10A we can write sin A by cos A. and this one we can write as cos A by sin A. Okay, so now we have taken LCM, so 1 by, it will become sin square A plus cos square A by cos A sin A. So sin square A plus cos square A will be equal to 1. So reciprocal of this A, so it will become sin A divided by 1 only, so cos A sin A. So we can see that RHS what we got cos A sin A, and LHS what we got sin A cos A or cos A sin A, both are equal. Hence proved. Okay, so the last question we are going to solve now. Okay, so LHS 1 is there, 1 plus tan square A by 1 plus cot square A. Okay, so 1 plus tan square A, the formula is secant square A. 1 plus tan square A is equal to secant square A, and 1 plus cot square A is cosecant square A. Right? Whereas it should be equal to tan square A. It is written tan square A. Or another words, there is no need to do that. Yes, there is no need to do that. No need to change. So 1 plus tan square A by 1 plus cot square A we can write as 1 by tan square A. So it will become 1 plus tan square A at the numerator. Here the denominator part will become reciprocal, so tan square A will come at the top, and here it will become 1 plus tan square A. So this and this has got cancelled, so left with tan square A. Now again in RHS, 1 minus tan A whole square by 1 minus cot A whole square. Right. So this also we can do. So simply 1 minus tan A whole square, we will not change it, and here will become 1 minus 1 by tan A whole square. So this will give us 1 minus tan A whole square into, again tan square A, this tan square A will go at the top, and tan A minus 1, tan A minus 1 whole square. So because that is square, it will not create any problem, right? So whether it is tan A minus 1 square or 1 minus tan A square, so there will not be any problem. Okay, so there is no difference between 1 minus tan A and tan A minus 1. Both are equal. So A square minus B square, A square plus B square minus 2AB. In both cases, we will be getting the same answer. Okay, so this tan A minus 1 whole square or 1 minus tan A whole square is equal and left with tan square A. Okay, right. So this is the answer. So we have seen that how systematically when we solve the questions, we are able to get each and everything. So as I said, let us move away from the general perception that mathematics is difficult. So thank you very much, my dear friends. Very soon I will be coming with another video. Do not worry, constantly I will be fulfilling your demand, and certainly the love and affection which you have given to me, I am very much thankful to all of you. Thank you. If you have liked, then do not forget to subscribe and share with your friends. Thank you.